Hello dear students, I think all of you have went through the previous sections of probability theory and you have studied all those things. Now we are going to see the probability in another way. Let us study what is it. Look at this example. First I will explain an example. Look at there are two bags. Bag 1 contains 6 red and 3 white balls. And suppose bag 2 there are 7 red and 2 white balls. Now I have written some questions here, you go through it. What is the probability of selecting a bag? You know there are 2 bags and you know the probability of one of them and you know it is 1 by 2. Okay, now look at the second question. What is the probability of getting a red ball? The question is, what is the probability of getting a red ball? We are taking a red ball and what is its probability? So you are in confusion. You know there are 2 bags and you have to think how many cases are there. In such case there are 2 cases. What are they? One student may select the first bag and he take a red ball, or he chooses a second bag and he takes a red ball. So there are 2 cases. Now we are considering, are they mutually exclusive? Okay, let us think about the cases whether they are mutually exclusive or not. If so, what is the probability of getting a red ball? We know mutually exclusive case. If A and B are 2 mutually exclusive events associated with a sample space, then you have probability of A union B, that is P of A plus P of B. Here also we come to the same thing. Now there is a change. Look at this. Suppose you know that the ball drawn is red. Then what is the probability that is from first bag? So here comes the change. Usually take the probability of a red ball, but here it is different. The question is, we are selected a red ball. If so, what is the probability that it comes from first bag or it may from second bag? So that is known as reverse probability. So today we are going to study the reverse probability. And before coming to the reverse probability or how to find the ball from first bag or second bag, we have to study some other things. The first and foremost thing is partition. Look at this. Partition of a sample space that you have to study. What is meant by partition of a sample space? For that, let us say a sample space. You consider a sample space. Then you consider some events, say E1, E2, E3, etc. En. There are n events defined on S. So there is a sample space and there are n events associated with S. Now you take the collection. I mean the collection of all events, that is set E1, E2, E3, etc. En. They are all events and we have taken its collection and E is said to be a partition on S. Okay, you can underline the word partition. Is said to be a partition on S if it satisfies the following 3 conditions. There are 3 conditions. The first condition, look at this, EI intersection EJ is equal to null set for all I not equal to J. That means E1 not equal to E2, E2 not equal to E3, E1 not equal to E3 and so on. So I and J can take values 1, 2, 3 etc. up to n. In that case we say the events are pairwise disjoint. There is no common element. So first condition is all these events must be pairwise disjoint. That means the intersection of any 2 of them must be null set. Then second case, you take the union of all events, E1 union, E2 union, E3 union, etc. union En. You take the union of all events and you have to get S. That is our full set, or you can say it is a sample space, and it is known as exhaustive. In words we can say exhaustive. And third condition, that is probability of EI. Probability of EI greater than 0 for all I equal to 1, 2, 3 etc. up to n. That means P of E1 greater than 0, P of E2 greater than 0, P of E3 greater than 0, that up to P of En greater than 0. That is non-zero probability. So if a collection of events E1, E2 etc. En satisfies these following 3 conditions, then we can say this is a partition defined on S. Once again you go through the condition. First condition, that is pairwise disjoint. Second condition, exhaustive. That means when you take the union of all events, you have to get S. Then third condition is probability of each event must be greater than 0. Now let us come to an example for partition. It's a well-known example. You have already studied this. Look at this. You take the experiment of throwing a die. What is the sample space then? It is S is equal to set 1, 2, 3, 4, 5, 6. Now you define two events A and B on S. What is A? A is set 1, 3, 5. I mean odd number. You take an odd number. Then what about B? 2, 4, 6, getting an even number. So the events are defined. Now you consider what is P of A and what is P of B. You know P of A, probability of A, it is nothing but 1 by 2. And what is probability of B? And it is also 3 by 6, that is 1 by 2. In both cases, you can see the probability is greater than 0. So the events have non-zero probability. Now what is A union B? You take the union of A and B. When you take the union of A and B, you will definitely get it as S. That is A union B is equal to S. So two conditions satisfied. First condition, non-zero probability. Second condition, when you take the union of A and B, you get S. Now let us come to the third one. What is A intersection B? Look at that. You take the intersection of A and B. If it is null set, we say they are disjoint. So that condition is also satisfied. A intersection B is null set, that is pairwise disjoint. So look at this. A and B satisfy all the conditions required for a partition. Hence collection. Remember this. Hence collection A comma B is a partition defined on S. Now we come to another important theorem that is known as total probability theorem. So concentrate on the statement. Let a collection of events E1, E2, etc. En is a partition on S. That is our assumption. Your assumption is now this one. That is set E1, E2, E3, etc. En is a partition on S. When you say partition, you have to remember all the three conditions. And now we take another event. Let A be any event associated with S. And in addition to the n events, we are considering another event, that is capital A. You take A. We can prove that probability of A is equal to P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus etc. plus P of En into P of A given En. Once again you go through this. How to write? P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus etc. The last one is P of En into P of A given En. And it can be written as summation sigma P of Ej into P of A given Ej. J varies from 1 to n. That is compact form of the above statement. Okay, summation P of Ej, P of A given Ej, and J varies from 1 to n. So this is a statement for total probability theorem. Now let us see how to prove this. Okay, for proving this, we need a Venn diagram. Look at this Venn diagram. You know that when you draw a Venn diagram, the universal set is replaced by S. So S stands for sample space. Now we have represented some events here. Look at E1 is an event, then E2 is another event, then this white portion E3 is another event, then you put some etc. Then last event you can take it as En. Okay, once again look at this. And here also you consider another event, that is capital A. You can see an oval shape of red, that is A. Okay, keep this figure in mind. This is our basic figure to prove the above theorem, that is total probability theorem. Okay, look at this. In the figure, you can see that A is the collection of union of all these sets. That is capital A is equal to A intersection E1. You take the intersection of A and E1. Then A intersection E1 union. Then A intersection E2 union. Then A intersection E3 union, etc. And take the last one, that is union of A intersection En. Also, all these events or intersections, that is A intersection E1, A intersection E2, A intersection E3, etc., A intersection En are all disjoint. You can see that they have no common part. So what is P of A? They are disjoint means they are mutually exclusive. In that case, you can take the probability by adding, as just like P of A union B is P of A plus P of B. Here also you can apply the same. A is the union of all these. So what is P of A? P of A is the probability. P of A intersection E1 plus P of A intersection E2 plus P of A intersection E3 plus etc. plus P of A intersection E. You have to remember one thing here. The only thing you have to do is you replace a union using plus. Then you will get P of A. Or in other way you can write P of A is equal to P of E1 intersection A plus P of E2 intersection A plus P of E3 intersection A plus etc. P of En intersection A. That means we have interchanged the A and EI. That's all. But you know the multiplication theorem. What is your multiplication theorem? Look at this. We know that P of A intersection B is equal to P of A into P of A given B. I have written in writing. Look at this. P of A intersection B is equal to P of A into P of A given B. Okay. So each term in the above equation can be replaced by that formula. So you can write P of A is equal to P of E1 into P of A given E1, then plus the next one is replaced by P of E2 into P of A given E2, then you continue plus etc. Then you write the last one, that is plus P of En into P of A given En. So this completes the proof. Okay, that equation can be written using sigma notation. That is P of A is equal to sigma P of Ej into P of A given Ej, where J varies from 1 to n. That means you can expand sigma, that is P of E1 into P of A given E1 plus, then you take 2, 3, etc. up to n. That's all. Okay. So you remember this is the proof. Now, based on this, we are going to study another theorem, that is Bayes' theorem. Look at this. You take a collection of events. If E1, E2, E3, etc. En be a partition on us. That is important. You study what is partition and keep in mind the meaning of partition. If the collection E1, E2, E3, etc. En be a partition on us and A is any event with a non-zero probability defined on S, then we can write probability of EI given A is equal to P of EI into P of A given EI divided by sigma P of Ej into P of A given Ej, where J varies from 1 to n. You have to study this by heart. Okay, once again I will read the statement of Bayes' theorem. If E1, E2, E3, etc. En, that is a partition defined on S. And suppose A is any event associated with S, then how to find the probability of EI given A? Given A means A, okay. Then what is the probability of EI? So in this case you can replace it using 1 or 2 or 3, whatever it is, according as our value vary. P of EI given A is equal to P of EI into P of A given EI, and the numerator is fixed, that is I. The denominator contains sigma, that means you have to expand, write down all the terms. That is sigma P of Ej into P of A given Ej, and J varies from 1 to n. Okay. Now let us come to the proof of Bayes' theorem. The proof is very simple. Look at this. You know the definition of conditional probability, how to write P of A given B. Here also P of EI given A. It is nothing but P of EI intersection A, the whole divided by P of A. Okay. Now using multiplication theorem, you can cross multiply it and write it as P of EI intersection A is equal to P of EI into P of A given EI. And by total probability theorem, that we have already proved, total probability using that Venn diagram, we have got this result. Okay, you combine those both. Therefore, you can directly write P of EI given A is equal to P of EI into P of A given EI, the whole divided by P of A, that is sigma P of Ej into P of A given Ej. This completes the proof. So if you want to prove the base theorem, you have to study the total probability theorem. If there is total probability theorem, you can simply write the proof. This completes the proof. Only two steps we need. One is for multiplication theorem and the other is total probability theorem. Okay, got the idea? Okay, dear students, when you come across with the problems, there may not be too many events. Sometimes there may be 3 or maximum 4. Most probably there are 2 or 3 sets. In that case, how we can write this formula? Okay, remember this. We usually come across with 2 or 3 events associated with S and with a given event A. So there may be 2 or 3 events, that is E1, E2 or E1, E2, E3 or E1, E2, E3, E4 sometimes, and in addition there is an A. Let us see. So these are the formulas you have to learn by heart. Look at this. Case 1, I have written there. Suppose there are 2 events E1 and E2 and a given event A. Then we use the formula. That formula can be reduced to this form. That is probability of E1 given A is equal to probability of E1 into probability of A given E1 divided by, since there are only 2 events, you can avoid sigma. You can directly write P of E1 into P of A given E1 plus P of E2 into P of A given E2. So that is for E1. That is the meaning of this probability of E1 given A is okay. A happened. That means we have taken the red ball. Then what is the probability that it comes from the first bag? That is reverse probability. Here we study that one. Okay. So the meaning is A appeared or A occurred. Then what is the probability of E1? So here you have to use this formula to calculate the reverse probability. Or sometimes it may be E2. We took the red ball. Then what is the probability? It is from the second bag. If the question is like that, you have to write that formula. Look at that. P of E2 given A is equal to P of E2 into P of A given E2. Then the denominator does not change. Both are same. Look at the only change comes in the numerator. That is when there are 2 events and given A. Now let suppose sometimes it may occur 3 events. Then E1, E2, E3 and capital A is the event already happened. So that is the case of third one. So in that case, P of E1 given A, P of E1 given A, that is yes, okay, then what is the probability of E1? So we have written P of E1 into P of A given E1. Then the denominator contains 3 times. Look at this, P of E1 into P of A given E1, then plus P of E2 into P of A given E2, plus P of E3 into P of A given E3. That is for E1. Remember, if it is for E1, you have to write the formula like this. And suppose the question is, what is the probability that it comes from the second bag? Then you have to use this formula. See, the numerator alone changes. All the denominators are same. Look at this. P of E2 given A is equal to P of E2 into P of A given E2. And you avoid sigma and write all the 3 times for E2. And similarly for E3, P of E3 given A is equal to P of E3 into P of A given E3, the whole divided by all the 3, that is P of E1 into P of E given E1 plus P of E2 into P of A given E2, then plus P of E3 into P of A given E3. Okay, keep in mind and study this formula. For all problems based on base theorem, we use these formulas. Okay, now let us come back to some problems based on base theorem. So this is a short question usually, so you have to study well. These problems are very simple. That means if you read it carefully and note down the events, then you can directly write the formula and you can arrive at the answers. Let us go through some of them. The first one is, an ale contains 5 red and 5 black balls, totally 10. A ball is drawn at random. A ball is drawn at random. Its color is noted. We note the color. We note the color. and returned to the air. We return it. Moreover, two additional balls of the same color are drawn or put in the air, and then a ball is drawn at random. So what is the probability that the second ball is red? There are also different cases. Case 1. So when you take a ball from the end, it may be red or black. So we are considering the first case, that is color noted is red and balls added are also red. Then probability of drawing a red ball. You know, totally there are 10 balls. So what is the probability of getting a red ball and what is the probability of getting a black ball? Both are equal to 1 by 2. Now probability of getting a red ball in case 1. So in case 1, what is the probability of getting a red ball? That is half into. Then as you know, when we add two more colors, two more balls of the same color, the first case becomes 7 red and 5 black. 7 red and 5 black. So you can write it as 1 by 2 into, in the second case that is 7. There are total 7 red balls and total 12. So its probability is 7 by 12. You have to multiply it 1 by 2 into 7 by 12. So your answer will be 7 by 24. That is case 1. Now the second case, color noted is black. So when you take a ball from the urn and it is black, it may be red or black. Red we have done. Now it is black. So balls added are also black. So in that case, the number of red balls do not change, but black balls changes. So it becomes 5 red and 7 black. So what is the probability of getting a red in case 2? It's also 1 by 2 into number of red balls, that is 5 divided by 12 and is equal to 5 by 24. So these are two cases and mutually exclusive. So how to write the required probability? The required probability is equal to 7 by 24 plus 5 by 24. So your answer is 12 by 24 and it is nothing but 1 by 2 since they are mutually exclusive. Okay, got the idea? Now let us come to second problem. I will read it. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Full stop. Then find the probability the ball is drawn from the first bag. Here we use the Bayes theorem, the formula for Bayes theorem. So look at this. The question is this one. There are 2 bags. The first bag, look at this. There are 4 red and 4 black balls. And in the second, there are 2 red and 6 black. And that is known as bag 2. Now, whatever be the question, when you apply Bayes theorem, you have to write all the required events first. Then only you proceed. Then you can easily answer the question. Okay, here we have defined 3 things. The first one is event. That is an event choosing the first bag. We are choosing the first bag. And E2, we are choosing the second bag. And third one, a ball drawn is red. These are the 3 importance in case you have to keep in mind. E1, E2 and EA. What is A? A is the actual event happened. You have to take it as happened event or occurred event. We know that we have drawn a red ball. So that is our capital A. A ball is red. Now you write the different probabilities. What is your probability of E1? That is choosing a first bag or choosing second bag. That is probability of E2. They are equal since there are only 2 bags. The probability of getting 1 bag is 1 by 2. So probability of E1 is equal to probability of E2 is equal to 1 by 2. Okay, now another thing, that is probability of A given E1. That is first case. Suppose we chose the first bag and we have taken a red ball. That is the first case. So what is P of A given E1? That is the meaning. So you know there are 4 red balls and total there are 8. So answer is 4 by 8. And what about P of A given E2? So when you write these probabilities, you must be very vigilant. So probability of A given E2 means we have chosen the second bag? If so, what is the probability of A? That is, what is the probability of red? And it is 2 by 8 since there are 2 red balls and 8 total. Now our question is not that one. Our question is, if A occurred, then what is the probability of even? That is, we have taken the red ball. If so, what is the probability that it is from the first bag? So this is our question. Probability of even given A. So you can write probability of even given A using Bayes theorem formula. This one. Okay, it is given in your textbook. You can refer it. And the only rest of the thing is you substitute the values. We have written all the values here. Okay, go through all this. See, numerator is 1 by 2 into 4 by 8. And denominator it is 1 by 2 into 4 by 8 plus 1 by 2 into, that is probability of E2 into 2 by 8. Then you do the simplification. Then you will get the answer. That is 2 by 3. That's all about Bayes theorem. The problem is very simple. But when you write all the details, there should not be any mistake. If you made a mistake here, your answer will be never correct. Okay. Now let us do another interesting problem. Look at this. This is an interesting problem. Usually there may be a chance of making mistake. So you must be very careful. And I think you can answer it yourself. I have written the answer on the right hand side. By looking here, you can do it yourself. So try yourself whenever you go through these questions. Okay, I will explain how to do it. Okay, there are 3 coins. There are 3 coins. One is a 2-headed coin. That means both are heads. Another is a biased coin that comes up with heads 75% of the time. So look at the second coin. It is biased. If you toss the coin, 75% chance is for head. And third is an unbiased coin. That is our usual coin. Then one of the 3 coins is chosen at random. Read it carefully. One of the 3 coins is chosen at random and tossed. It shows head. Then what is the probability that it was 2-headed coin? That is your question. I think all of you have understood this. Now based on this question, again we are going to define 3 events. Here we need 4 events because there are 3 coins. Okay. In the previous question we have already only 3 events. Here we need 4 events. First one, E1. That is choosing the first coin. We are taking the first coin. E2 choosing the second coin. And E3 we choosing the third coin. So there are 3 different cases, E1, E2 and E3. So you know the probability of E1. What is the probability of E1? And since there are 3 coins, the probability of getting a coin is 1 by 3. So the probability of E1, probability of E2 and probability of E3 are all equal and equal to 1 by 3. Okay. Then in addition to these 3 events, we have to define another event also. That is the event what actually happened. Look at that. One of the 3 coins is chosen at random and tossed and it shows head. That is important. So your A is head appeared. You take capital A as A, okay. Then you know the formula for probability of even given A. And the question is, what is the probability that it was a 2-headed coin? 2-headed coin means from the first event, that is even, choosing the first coin. So our formula is probability of even given A. That is our formula. So you have to write P of E1 into P of A given E1 divided by P of E1 into P of A given E2 plus etc. Then P of E3 into P of A given E3. This is our basic formula. Now you write P of A given E1. P of A given E1. That means E1 occurred. Then what is the probability of A? This one. Probability of A given E1. So E1 is a 2-headed coin. We are choosing the first coin. It is 2-headed. So the probability of getting a head is 100%. That is 1. Then what is the probability of A given E2? E2 means we are selecting the second coin and it is a biased coin. 75% comes up head. So what is it? Probability of A given E2 is equal to 75% is, in probability you have to write it as fraction, that is 75 divided by 100 and it is 3 by 4. And third case, it is a unbiased coin, so its probability of A given E3, it is 1 by 2. Since the coin is unbiased, you know head or tail occurs 50%. So answer is P of A given E3 is 1 by 2. Then our last question is, what is the probability that it is two-headed coin? So we have to find probability of E1 given A. You put a question mark. So before writing the formula, it is better to write all the given quantities in the question. So once again, we will go through all this. Look at this. Write P of E1, then P of E2, then P of E3. If there are 3 events, you have to write P of E1, P of E2, P of E3 first. Then based on that, then you write P of A given E1, then P of A given E2, then P of A given E3. These are the things we have to write first. Then you think about what is the question. Here the question is, what is the probability that it comes from the first coin? So it is like this, probability of E1 given A. Now the only thing is you have to substitute. I think you can do this. Just to substitute all the values. All we have written here. You need to look at that. You can directly write the formula and substitute for it and you will arrive at the answer. So I have written it there and our answer is 4 by 9. Okay, go through it and do it again. Now let us stop here. We have done all the important questions here. You go through it and study well. What is total probability theorem, partition, then Bayes theorem and its formula. Then you go all those things and there are more questions in your textbook. You open the textbook and try to solve all those things, and there are some solved examples are given. Okay, have a nice day. Wish you all the best. Thank you all once again.